Now, okay, here's a couple more examples. Let's say we took our two kidnapped guys. You don't forget about them. We didn't forget about them. We didn't leave them in those boxes. Now this time, we are going to put them in a skyscraper. Okay? We're going to put them in a skyscraper. One of those guys, we're going to put on the ground floor. And one of them, we're going to put on the top floor. Now, first question. Let's put this is guy A, and this is guy B. Okay? Guy A is at the top, guy B is at the bottom. Who feels more gravity from the Earth? Guy A or guy B? Who feels more gravity from the Earth? Guy A or guy B? Guy B, right? B feels more gravity from the Earth because B is closer to the Earth. Okay? B is closer to the Earth. So B feels more gravity. So, because B feels more gravity than A, that means time is different for them. Guy A or guy B, who has slower time? Who has slower time in this scenario? A or B? Well, according to our clocks here, B again. Yeah, B. So, that means that everything down here is happening more slowly on the ground floor than it is on the top floor. And it wouldn't really be a noticeable difference on Earth, but let's say we took this skyscraper off of the Earth and we put it down on a neutron star. Now, guy B would feel a lot more gravity than guy A. So what that would mean is time is a lot slower on the ground floor of this skyscraper on the neutron star than it is on the top floor of that same skyscraper. Okay? Now, let's say that this guy up here, guy A, can see through the floor and look at guy B. If he does that, because time is slower down here, what's going to happen is guy A will say, oh, B is in slow motion. Because time is slower down here, it's not just clocks going slower, it's everything. So guy A would see B going like this. And like if guy B dropped something, it would drop in slow motion. And everything goes in slow motion. So, if you look at someone that has more, if you look at someone that's in more gravity than you, because time is slower there, everything will be in slow motion from your point of view. But, would guy B know he was in slow motion? Yes or no? Would guy B know he was in slow motion? Yes or no? Because remember, everything is in slow motion down there. Would he know it? No, he wouldn't. He wouldn't be able to tell he was in slow motion because if everything is in slow motion down here, then that means that includes like the circulation in his body, and it includes the thoughts in his head. It includes his senses. So his senses and his thoughts slow down at the same amount that everything around him is going. So everything would look normal to him. He would say, oh, things are dropping normal. I'm talking normal. Everything's normal. If guy A looks at him, guy A sees him going, everything's normal. So let's turn this around. What would guy B see if he looks up at guy A? Well, now, if he does that, he's looking at somebody who has less gravity than him. So what will guy A look like from guy B's point of view? What would it look like up here from that guy's point of view? Because he's not looking at somebody with more gravity. He's looking at somebody with less gravity. Faster. Everything up at the top would look like it was in fast motion for the guy at the bottom. So A sees B in slow motion, and B sees A in fast motion. And somebody's actually pointing out a very important point here. So this is not like in special relativity where they both saw each other in slow motion, because in special relativity it was just a different speed that caused that. It didn't matter if their speed was faster or slower than them. They both saw each other's time as slowed down. But here, it's the amount of gravity that determines what you see. Again, if you look at something with more gravity, you'll see it in slow motion. And if you look at something with less gravity, it'll look fast motion to you. Okay? So here's my last question about this before we start really trying to apply this stuff to black holes. Let's say that these twins, let's say when we kidnapped them, they didn't know it, but we put a bomb in their chest. We put a bomb inside of them because we're mad. Clearly, we're mad scientists. Don't do this, but clearly in this story, we're mad scientists. We're kidnapping people. We're putting them in space. We're just doing crazy stuff. So we put a bomb in their chest, and those chest bombs inside have a timer. They're set to blow up at the same time. Okay, they're set to blow up at the same time. And don't worry, we're not a mean mad scientist. We've set it so that it'll blow up when they turn like 75 years old. They've had like a nice long life. We'll give them 75 years, okay? But they're gonna live in this skyscraper the whole time because we're mad scientists. Okay, now, here we go. Are they gonna die at the same time? Yes or no? No, they're not. Who's going to get to live longer? A or B? Who's going to get to live longer? B gets to live longer because everything is slow motion down here. Okay? Everything is slow motion down here. Will B know that will he feel like he lived more than 75 years? Will B feel like he lived more than 75 years? No. His 75 years are longer than the 75 years up here because the 75 years are slower, but they will feel normal. Whenever you go into one of these high gravity situations, you slow down with the time. So this is not a way to make it feel like you lived longer, but technically, even on Earth, your seconds are longer on the ground floor. By the way, here we go. Have any of you guys seen the movie Interstellar? Have any of you guys seen the movie Interstellar? If you haven't, we're going to spoil it anyway. It's been enough years. If you haven't seen it yet and you were hoping to see it, it's too late. I'm going to spoil this movie, okay? I'm going to spoil this movie in a lot of ways. Check this out. Let's go ahead and apply this to a black hole in one way. Oh, please stop freezing on me. Technical difficulties. Here we go. All right. So, in that movie, there's a black hole. So let's just singularity, event horizon. Let's say that this is the black hole over here. There's my black hole. And there's a planet orbiting around that black hole. So black hole, and I'll put a P on this for planet. And what they do is they park their spaceship way away from the black hole. So, whatever, that's the spaceship. There we go. And because they park it way away from the black hole, they parked it far enough away that they're not going to fall in. Ugh, I'm getting terrible lighting right now. Ignore the green screen starting to show through. Okay, now, what they do is they leave one guy behind on the ship, and most of the crew gets in like a little lander and launches off, and they end up going down and visiting this planet. And they stay there for like 20 minutes. They stay there for like 20 minutes. Okay? And for those of you who have seen the movie, hopefully you remember how this movie worked. They stay there for like 20 minutes, and then they go back to their spaceship. And what has happened to this guy on the spaceship in that movie? What do they notice when they see this guy? Well, for those, if you don't, it may have been a while. I'll go ahead and tell you. What's happened to that guy, again, spoilers start here. This guy has aged like 15 years. This guy has aged like 15 years in the time that they spent on that planet. They spent like 20 minutes on that planet, and they come back, and this guy has aged like 15 years. Now, why is that? Why is that? Well, when these people went to this planet, that's really close to that black hole, so they're feeling a whole ton of gravity from that black hole. So what was happening to their time when they visited this planet? What was happening to their time when they visited this planet? It slowed down a lot, and they didn't realize it, because they were slow motion too. So when they came back out, their 20 minutes close to the black hole was like 15 years out here. So yeah, he waited a long time. He waited a long time for them to come back, right? This is not the same thing as time travel. Because all it really is they started moving slow motion for a little while, and then they came back to more normal when they went away. It's not the same as time travel. It can make you, you can experience the future because of this, but you're not really, you're not teleporting to the future like in time travel movies. All you're doing is slowing your own body down so that you age slowly, and then when you come back out of that gravity, things go back to normal. And here's why this is not like time travel. If they got out here and they were like, "Oh no, you're so old. Sorry about that. Let's go back." If they tried to go back to the planet and wait 20 more minutes to come back, would that solve the problem? Would that make it so that the guy was young again out here? Would that get them back to where they came from? Yes or no? No. If they did it again, what would happen? What would happen if they did it again? He'd just be older now. He'd be even older the second time. So again, it's less like time travel and more like putting yourself in almost suspended animation, sort of. Just not completely suspended. You're just slowing your entire existence down when you go into that gravity. So, yeah, it's weird. That part of the movie was accurate. That could actually happen if that's happened. I'd be amazing. I can't remember in the movie if if they knew that this was going to happen, and so the guy was like, I know that this is going to happen, and I'm going to wait. Because, if they didn't know that was going to happen, then you'd think he would be like, they're probably dead. And he'd just, like, dip out. But, there you go.